Good day, everyone. I'm Miss Romulo, and I'm the first reporter of the Group 10, and I'm going to discuss about the Chapter 10, and the title of the chapter is all about statistics and computer tools for analyzing of assessment data. So for most educators, just hearing the term statistics conjure images causing anxiety, even to those educators who do not consider themselves numerically deficient. Statistics intimidates them. In descriptive statistics, which will be the focus of discussion in this chapter, the emphasis is on describing a set of scores. Description may take the form of tables, graphs, or as a single number, for example, an average. In this chapter, the basic concepts of statistics, the relevant statistical treatment that can facilitate the interpretation and analysis of data, as well as the use of computer as aid in analyzing and data presentation will be covered. At the end of this chapter, you should be able to first utilize process data and results in reporting, and lastly, interpreting learners' performance. Many teachers think that statistics requires advanced mathematical skills and tedious calculations. The elementary statistical concepts necessary in organization, interpretation, analysis, and presentation for evaluation of grades and scores of students is not what majority thinks of. At present, not only calculators are at hand to facilitate computations, but most especially computers and some software which are available for statistical computation and treatment. The statistics that is discussed in this chapter is descriptive in nature, and brief overview of inferential statistics is given. The three types of statistical measures covered in this chapter are measures of central tendency, measures of variations, and measures of relationship. The statistical treatment for individual data subject to interpretation is also covered in this chapter. So, the fir- uh, what is statistics? Statistics is concerned with the organization, analysis, and interpretation of test scores and other numerical data. Statistical techniques helps teachers to analyze and describe results of measurement obtained in their own classrooms, understand the statistics used in test manuals and research reports, and interpret the various types of derived scores used in assessment. Statistical methods enable us to look at information from a small collection of people or items and make inferences about a larger collection of people or items. Procedures for analyzing data, together with rules of inference, are central topics in the study of statistics. Brace and Brace 2012 defines statistics as the duty of how to collect, organize, analyze, and interpret numerical information from data, and that is statistics. Second, we have the descriptive and inferential statistics. Descriptive statistics, this is used to describe a group of individuals, or describe the data that have been collected, to describe variables that were grouped in order to determine the measure of certain dependent variable that needs to be measured. Various data analysis techniques provide meaningful description of scores with small number of numerical indices. Such indices are calculated using samples drawn from a population and are called statistics. On the other hand, when indices are calculated using the entire population, it is called parameters. This type of statistics is used for summarizing and describing data sets. While inferential statistics, it is when there is a need to make a decision, estimate prediction, or generalize about a population based on a sample. Then, inferential statistics will be utilized. There are two types of tests in inferential statistics. These types are the parametric and non-parametric. In parametric test, a test of significance is used if the data represent an interval or ratio scale of measurement and other assumptions have been met. On the other hand, non-parametric test is used when data represent an ordinal or nominal scale, when a parametric assumption has been greatly violated, or when the nature of the distribution is not known. Third, we have the statistical tools. To carry out meaningful comparisons among sets of test scores, a statistical tool is needed. Measures of central tendency and measures of variability are the most commonly used statistical tools. So, here we have the measures of central tendency and its characteristics. First, we have the mean. Its first of the mean characteristics are most frequently used index of distribution central tendency. Second, it is simply an arithmetic average of all the scores in the distribution. Third, since it is computed using every score in the distribution, it is an extremely representative measure. Lastly, its strength is also its weakness because several atypically high or atypically low scores, sometimes called liars, can distort the value of the mean. Next, we have the median. Its first characteristic of the median is the second most frequently used index of central tendency. Next, it is the point that divides the scores into two equal halves. And next, one advantage of median as a measure of central tendency is that it is not unduly affected by peculiarly large or small scores. Next, unlike the mean, the median treats each of these wild scores as merely another score, no more, no less than other scores. Lastly, as the mean, the median strength is also its weakness. The median fails to reflect the magnitude of the impact of every score in the distribution, even when certain of those scores are very high or very low. Lastly, we have the mode. It is the most frequently occurring score in the distribution. With most reasonably large set of scores, the mode will occur somewhere near the middle of the distribution, so it can also serve as an index of the distribution's central tendency. In some cases, a distribution has two or even three most frequently occurring scores. In such cases, statisticians refer to it as bimodal or trimodal distribution. Multimodal distribution refers to those with three or more frequently occurring scores. And lastly, since the mode takes into account even fewer data than the median and fewer than the mean, it is not used often in describing a distribution's central tendency. I think that is all my part. Thank you for listening, and the next reporter will continue the lesson.
Hello everyone, so let's continue the chapter 10, the measures of variability. Aside from describing how a set of scores tends to the center of distribution, the information about how variables the score are is also important. It is also relevant to know how to spread out the scores are. So, the measures of variability and characteristics. First is the range. Range, it has three characteristics. First, most readily calculated index of distribution's variability. Second, it is calculated subtracting the lowest score from the highest score. Third, the simplicity of the range computation is just only the redeeming virtue because there are only two scores involved in its computation. If there is an abnormally highest and or lowest score, the resulting range will yield a misleading indication of the distribution's overall variability. Second, second measures of variability is the quartile deviation. Quartile deviation, it is based on the range of the middle 50% of the scores instead of the range of the entire set. It is semi-interquartile range. Quartile points are on the scale like averages and percentiles. The quartile deviation represents a distance on the scale. It indicates the distance that is necessary to go above and below the median to include approximately the middle of 50% of the scores. Semi-interquartile is the half of the quartile. Third measures of variability is the standard deviation. It has 5 characteristics. First, it offers a way of thinking about the average variability of a set of scores when they compute the mean. It tells the average distance from the mean for each of the scores in the distribution. Third, the more spread out of the scores are, the larger the value of the standard deviation. The less spread out the scores, the smaller the standard deviation is. It is the most useful measure of variability because it takes into account the amount that each score deviates from the mean. It is more stable measure of variability than the others. In summary, the quartile deviation is used with median and is reasonable for analyzing small number of scores. These statistics are obtained by counting and thus are not affected by the value of each score. They are especially useful when one or more scores deviate markedly from the others in the set of scores. On the other hand, the standard deviation is used with the mean. It is a most reliable measure of variability and it is especially useful in testing. Also, it is useful in describing the set of scores in a group. It serves as basis for computing standard score, the standard error of measurement, and other statistics used in analyzing and interpreting scores.